Everybody hear me okay? Yes. My name is Corey Shell. I'm a senior cybersecurity consultant with Dean Norton. And the purpose of this talk is I'll be speaking from a perspective of a cybersecurity consultant who's performed technical security assessments for the past 4 years. So a little bit of background on me. I've been doing cybersecurity assessments for over 4 years. Prior to that, I had several years of IT security experience. So the agenda today, we're going to cover some areas that we typically perform security assessments for, starting with cloud security, external security, which is your internet-facing security, account security with a focus on Active Directory and local account and password management. And then we'll go over endpoint security, so that's the security of your endpoints. We'll also cover some common security controls. And then we'll close with some free tools as well as informative references that might be helpful for you. And I'll take questions at the end of the presentation. So to start with cloud security, we're going to have a very heavy emphasis on Office 365 and Azure, so we're not really going to be covering AWS or other cloud platforms. Can I just get a show of hands? How many people here use Office 365? Okay, so this is going to be very relevant for a lot of you. So we're going to start off with some statistics from Microsoft. So pertaining to identity attacks, they observe roughly 300 million fraudulent sign-in attempts daily. 81% of breaches are caused by credential theft. So a big topic of this presentation will be credential theft. And according to Microsoft, 99.9% of attacks can be blocked with multi-factor authentication. So we're going to spend some time talking about MFA and how that can be bypassed. So these numbers are from Microsoft's latest Ignite conference. They've observed a 300% increase in identity attacks over the previous year. So in a single month, they observed roughly 23 million high-risk sign-ins that appear to be indicative of phishing. They observed 350,000 accounts that were compromised in a single month by password spray attacks. We're going to cover password sprays a bit more in depth here in a minute. And then 4.6 billion sign-in attempts detected in a single month. Breach replay. Breach replay is also referred to as credential stuffing. That's where threat actors or attackers take a bunch of usernames and passwords that have been disclosed in data breaches, and they replay those for other services. So here's a list of some very common observations that we observe when we do a cloud security assessment. The first one is that either the organization is unaware of what their secure score is, or they're not aware of what a secure score is. If they are keeping track of it, it's not actively maintained. We're going to cover that a bit more in depth in another slide, but it's basically a metric that Microsoft reports to you on the status of your security controls in your cloud environment. We also see a very low rate of adoption for multi-factor authentication. This also includes highly privileged admin accounts, such as global administrators. Legacy protocols are enabled. This is a default setting for Exchange mailboxes. This allows threat actors to target those mailboxes with password spray attacks. We'll cover that more in depth here in a minute. We also see that auditing is not enabled. So this is a default setting. You have to proactively enable auditing. Otherwise, if you have an incident, you can't retroactively enable the auditing and have those logs available to you. If it's not enabled at the time of the incident, then those logs are not available for your investigation. And then the last observation here, that typically what we see is that the IT staff are unable to retrieve sign-in logs or investigate risk events with the proper context because they lack the necessary licensing to do so. So it's worth noting that most Office 365 licenses do not include Azure AD Premium, and we're going to go over some of the things that are included with that Azure AD Premium license. So to start with the secure score, there's actually 3 different types. So I've seen some confusion on this. There's a Microsoft secure score, which includes a rating on 6 different categories. There's an identity secure score that applies to your Azure Active Directory. And then there's an Azure Security Center Secure Score. That's only relevant if you are using Azure for your infrastructure, for your virtual machines. To give you a picture of what that looks like, here's the Microsoft Secure Score. You can see on the left-hand side, you get a total score. You see what your score is in each of those categories. The Identity Secure Score is taken directly from the Azure Active Directory Secure Score. This is a metric that is based on the controls that you've implemented in your environment. So to give you an example, requiring MFA for all your users, that would improve your score by 30 points. That would also greatly reduce your risk of mailbox compromise. Enabling auditing, that would be another 15 points. And you can see here, it also gives you it shows you how you compare to your peers in your industry. So it shows you what the industry average is, the global average, and then what your score is. So I highly recommend you check out what your secure score is and take a look at those improvement actions and how you can improve your score. Multi-factor authentication, this is the big thing if you want to reduce your risk of compromise in Office 365. So multi-factor authentication, it's a combination of two of the three here: something you know, something you have, something you are. Something you know, such as a password; something you have, such as a device, could be a YubiKey, like a physical device. Something you are, such as a fingerprint. Whenever you enroll an MFA in Office 365, you're greeted with this screen here that allows you to choose the type of MFA you'd like to use. So the type of MFA we recommend that you use is an authenticator app, so a software token. It's worth noting that if you use text messages or SMS as your form of your 2FA, that can be circumvented by threat actors by what's called SIM hijacking. So they social engineer your cell phone provider. They get them to swap the SIM card, and then they can get a text sent to their phone number. There was also a tool that was released on GitHub earlier this year called Modlishka, and that allows a threat actor to proxy traffic to Microsoft. So if you are doing a push, it can allow them to set up a fake website where they can harvest your credentials and then proxy your second factor as a way they can bypass your MFA. So according to Microsoft, only X% of all Office 365 admin accounts require MFA. Anybody want to take a guess as to what this number is?
100%.
1.8%. So, and we see that too whenever we do assessments. There are very few privileged admin accounts that have MFA enabled. So this is one of the most critical things you can do to improve security in your cloud, is make sure you've got MFA enforced for all of your privileged users. Now, we mentioned password sprays earlier. So earlier this year, security researchers at Proofpoint had a study. They found that roughly 60% of Office 365 and G Suite tenants are targeted by IMAP-based password spray attacks, and roughly a quarter of those experienced a breach as a result. So password spray attacks are very common. And really the best way to mitigate this is to disable legacy protocols like IMAP, POP, and SMTP. It's worth noting, even if you've deployed multi-factor authentication for every mailbox in your Office 365 environment, but you haven't disabled these legacy protocols, the threat actors can still get access to those mailboxes. So pushing out MFA is not enough. You need to also proactively be disabling these legacy protocols. Australian Cybersecurity Center released an advisory on password spray attacks earlier this year in August. I would encourage you to take a look at that. So what's the impact of disabling legacy authentication? Well, if you've got older clients in your environment, so if it's older iOS or Android handsets that don't support modern authentication, it will break them. If you've got older versions of Microsoft Office pre-2013, it will break them. If you've got Office 2013 deployed, that requires a registry change to actually support modern authentication. So before you disable legacy authentication, especially if you're going to do it tenant-wide, you need to review your sign-in logs in Azure so you can know exactly which users are going to be impacted if you were to disable this globally. However, you can't access those sign-in logs unless you have an Azure AD Premium license. So your IT admins need Azure AD Premium license to get these sign-in logs.
Do they just need a license for themselves, or
Just for themselves,
for every user?
Not for every user, no.
Okay.
So something else, if you're an IT admin and you're investigating potential incident Office 365, like a mailbox compromise, if you're just using Azure AD Basic or free, you can see that screenshot at the very top right. That's exactly how much context you get: a user, an IP, a location, sign-in time. There's very little context about why that risk event was generated. But if you have an Azure AD Premium license, you get much more context about the user agent, the operating system, geographic location. You see the risk event type, so it tells you exactly which type of risk event was triggered. So those Azure AD Premium licenses are extremely beneficial to your IT admins if they're going to be investigating potential incidents in Office 365. So we talked about audit log not being enabled by default. This is the unified audit log. It's not enabled until a global admin goes to Security and Compliance Center, goes to audit log search, and clicks that turn on auditing button. So be sure to do that. That should also increase your secure score probably 15 points. So Microsoft has a feature that requires Azure AD Premium. It's called conditional access. So these are, when this happens, then do this type of conditional policies you can implement. So I'll give you an example. We've got a client that we basically helped enforce geofiltering for. So we block sign-in attempts from anywhere outside the United States, and that's using conditional access. Now, each user that the conditional access policy applies to needs an Azure AD Premium license. So if you wanted to deploy a conditional access policy tenant-wide, you would require a premium license for everybody that applies to. However, Microsoft does throw you a bone every now and then. These are baseline policies. So these are policies that are available to every Azure tenant regardless of your licensing. So it doesn't matter if you're just using Azure Basic. The downside to these baseline policies is they're not really customizable as much as the Azure Premium conditional access policies are. These are basically on or off. So you can't make exceptions. But they are there. They're currently in preview. Hopefully, whenever these are no longer in preview status, they will allow for exceptions. I can take questions at the end. Now, this is a checklist. I highly recommend you check out this checklist. So starting at the very top, Microsoft has an Office 365 security roadmap. They tell you what your top priorities for the first 30 days, 90 days, and beyond are. Now, all of Microsoft's recommendations and this, as well as their secure score, are Microsoft-centric. So they're telling you what controls they offer that they recommend to increase your security. But it's worth noting that they do allow for whenever you go to make changes in your secure score, you can check resolve via third party. So I highly recommend if you're using third party products for like DLP or mobile device management, be sure and update your secure score with those controls that are satisfied by a third party. Also, the Center for Internet Security has some benchmarks for Azure and Microsoft 365. These are very detailed walkthroughs on how you can audit security controls in your environment and how you can remediate those issues as well. So we're going to move on to external security. So some common observations here. This is the security of your internet-facing environment. So typically your internet-facing servers or servers in your DMZ. We typically see management interfaces that are exposed to the internet, including SSH, Telnet, RDP. And let me tell you that you do not want to have RDP internet-facing in 2019. We'll cover that a bit more later. We also typically see single-factor authentication, even for like the VPN as an example. So in that case, a threat actor only needs to get one user's credentials to potentially gain access to the internal environment if that user is a VPN user. We also see a lot of misconfigurations. So these are systems that are put in either internet-facing inadvertently, or they're not scanned and checked for vulnerabilities and have a checklist to make sure that they're not introducing vulnerabilities to the internet-facing environment. unknown or unsupported assets exposed to the internet. So there's either systems that were set up by a vendor or maybe have a core operating system that's no longer supported by the vendor, that's end of life, being exposed to the internet. We also see, we find things in GitHub repositories, things on websites that are useful for staging an attack when we perform open source intelligence gathering. Okay. Now there's a lot of slides to this one. We're going to cover account security. So this is mostly focused on Active Directory and password management and local account management. So we'll start here at the top. The most common observation is weak passwords and an insufficient password policy. So we're going to cover good password practices at a bit more depth here in a minute. We see a lot of users who pick passwords using formulas like password 1 exclamation, fall 2019 exclamation, etc. We'll talk about how you can improve password security here in just a minute. We also see a lot of principle of least privilege violations. So a lot of users are local admins. We see IT admins that use their domain admin accounts to perform high-risk activities like browsing the web or checking their email. We see local admin account password reuse on multiple machines. We'll cover that a bit more in depth here in a minute, why that's a big security issue. Domain admins logging in everywhere. That's not a good security practice. We're going to cover that a bit more in depth when we get to credential theft. Service account passwords, they're typically, so we see service accounts that have passwords that are changed very infrequently, usually have the password set to never expire. We also see password stored in group policy preferences. We'll cover that a bit more in depth here in a minute, why that's a bad idea. And then occasionally, I don't see this as much anymore, we see passwords stored in the description field in Active Directory. That's not a good idea because that by default everybody has read access to that, so it's not even security through obscurity. So starting out with the insufficient password policy. So these are some very common weak passwords there that we see. The common password formulas. When you have just the native password policy settings in Active Directory, we see this everywhere we go. About the only way you can really mitigate this is good security awareness training and also a password filter. So the latest guidance from Microsoft is probably it may seem counterintuitive when you consider what we've been told for years. They recommend maintaining at least an 8-character minimum length requirement. They don't require character composition requirements. That means they do not require complexity. So digest that for a second. They're telling you that you don't need upper or lower number special. Don't require mandatory periodic password resets for user accounts. That means don't expire your passwords every 90 days. So, however, those recommendations are contingent on this next one, banning common passwords. That means using a password filter, some technical control that prevents users from picking passwords like we mentioned previously, a formula like password 1 or fall 2019. Educating your users not to reuse their passwords for non-work related purposes. So this is something that gets a lot of organizations is their users reusing passwords that they use externally for their password for their Active account. And then also, you shouldn't be enforcing registration for multi-factor authentication. So Microsoft does have a password filter that will work with your on-premise Active Directory. It does require an Azure AD Premium license. It's called Azure AD Premium, it's called Azure AD Password Protection. There are a couple other commercial solutions. I've actually worked with the one there in the bottom, a Nixus Password Policy Enforcer. We were able to use a banned password list of over 500 million passwords. So we prevent our users from picking a password and those one of those 500 million. So it's kind of a carrot and a stick. You're hitting your user with a stick and telling them they have to pick a really good password, and it may take them 10 or 15 minutes, but you're giving them a carrot because they don't have to change their password as frequently. They should only have to change the password if you confirm or suspect their account's compromised. When you force your users to change their passwords frequently, they usually pick a formula and then slightly alter just a single character every 60 or 90 days. So Microsoft did have a password length restriction on cloud accounts that was a minimum of 16 characters, a maximum of 16 characters. So you couldn't set up an account on Office 365 with more than 16 characters. They did remove that. They now allow for up to 256 characters. So I highly recommend setting up lengthy passwords, preferably random and unique, for your privileged users, and storing those in a password vault or password manager. So we're going to talk about password managers. In 2019, all of your passwords should be random and unique and stored in a password manager. You should only be relying on, really need to remember a password to log in your computer, and then a master password for your password manager. And then all your other passwords you maintain in your password manager should be random and unique. Password reuse is what gets a lot of organizations hit. Now, one common question that we get when we talk about password managers is, should we really be putting all of our eggs in one basket? And my answer to that, I'm going to quote Troy Hunt, who maintains a website called Have I Been Pwned. Password managers don't have to be perfect. They just have to be better than not having one. So like anything else, password managers do have vulnerabilities. They're software. There was some security researchers that found some vulnerabilities in password managers earlier this year, but they're much better than just saving all of your passwords in Excel spreadsheet or Word document on your desktop, or just reusing the same password everywhere. So that Troy Hunt's website, Have I Been Pwned, they do maintain a list of over 8 billion accounts that have been compromised. These are a bunch of data breaches. You can check to see, if you go to this website, enter your email address, you can see what services you've used your account's been compromised in. They also allow you to download the password list that they maintain. It contains over 500 million passwords. Okay, so now we're going to talk about credential theft. So this is a screenshot of a tool called Mimikatz. So this is something that pen testers and adversarial threat actors will use when they gain a foothold to a workstation environment. They will dump the credentials of logged in users and then attempt to move laterally in the environment with those credentials. And here lately, there have been malware that have actually incorporated this tool. So we're going to cover that a bit more in depth when we get to the endpoint security section. But I wanted to point out, when you log in interactively, that means when you log in at the console on your computer, or if you log in with a remote desktop session, your credentials are exposed in memory. So that means whenever you log in as a domain admin on a workstation, if a threat actor has a foothold or if malware has a foothold on that computer and it's using a tool like this, it can dump your credentials and then use those credentials to move laterally. Another issue that I've seen pretty commonly is group policy preferences. So back in 2014, Microsoft had a feature in group policy preferences where it allowed you to store a password in group policy. It would be stored in an encrypted value that everybody had read access to on the sysvol share, because by default every domain user has read access to sysvol. This was encrypted, and if you look at the top left, it used to have that message that this password is stored as part of the group policy object and is discoverable, although obscured. After Microsoft released a patch to update that in 2014, then it said, this preference requires the cpassword attribute, which is a known security risk to help protect your environment. Some actions may not be available. That basically stop you from using it. However, if you had already deployed your policies storing that password, they didn't retroactively get disabled. So what I'm seeing is leftover group policies that were deployed several years ago that are still in effect. They're still storing passwords that haven't been changed, and it's basically a privilege escalation vulnerability that once a threat actor gains a foothold on any computer in the environment, if you've got this, these group policy preferences, they can escalate their privileges to the account that has that password stored in group policy. So Microsoft has a roadmap called their Securing Privileged Access Roadmap. I've got the link there at the bottom. There's really no reason not to implement this for any organization. The very first step here is separate accounts for admin and productivity tasks. The next step is just-in-time local admin passwords. Microsoft's got a free tool we're going to cover a bit more in depth here on the next slide called Local Administrator Password Solution that allows for random and unique passwords for all workstations and servers. The third phase here is a privileged access workstation. We'll cover that more in depth in a second. So part of this securing privileged access material is a tiered privilege access model. So usually most environments we see IT admins have two accounts. They have a regular user account that they might use to check their email, surf the web, and then they have a highly privileged account they may use to access a bunch of servers, so that infrastructure throughout the environment. This model, instead of having two accounts, you would have up to 4 accounts. You would have an unprivileged user account, you would have a workstation admin account, a server admin account, and then a domain admin account. And this is key. The domain admin account can only be used on the domain controllers. It can't be used to sign on anything else. So the first step of implementing this type of access model is actually creating the separate accounts for users, making sure they're pushed out to the local administrators groups on workstations and servers. The second part of this is pushing out group policies, which actually restrict those tier 0 accounts from logging into tier 1 or tier 2, and the tier 1 accounts from logging into tier 2. We'll cover why that's important here in the endpoint security section. So separate administrative accounts, you should really have a standard user account that you use for higher risk activities, preferably on a system that is not the system used to manage everything in the environment. And then you should have administrative accounts, preferably that tiered model that we mentioned before. So we mentioned Labs earlier. This is a free tool from Microsoft. It's managed through Active Directory and group policy, and it allows you to set a unique and random password on all member servers and workstations for the built-in local administrator account. The reason this is important, like we talked about that malware and threat actors using tools like Mimikatz earlier, if you use a shared password for the local admin account on multiple systems, all it takes is one system to get compromised, and then the threat actor can pivot to every other system that has that shared password. So you can mitigate that by using this free tool that ensures that the local admin passwords are all random and unique. If the threat actor dumps the password hashes, they can't pivot to other systems because it's unique to that system. There's a technique called curve roasting. We're not going to, for the sake of brevity, we're not going to cover too much in depth. But what you need to know to really mitigate this, you really need to focus on securing your service accounts. You should be running at least 2012 domain and force functional to use this, but you can have random and unique passwords managed through Active Directory for your service accounts. If for whatever reason you have service accounts that maybe a vendor requires to be set up like a regular user account, we recommend that you ensure that those service accounts at least have a 25-character linked password. They should be random, unique, and stored in a password manager. You can also use fine-grained password policies to set longer password length requirements for service accounts. So you can have a minimum 25-character password requirement for service accounts while you have a password policy that is less stringent for your regular users. So we mentioned privileged access workstations earlier. So this is a term Microsoft refers to as PAWS. It's basically a hardened and locked down workstation for your IT admins. So this would be a locked down system your IT admin would use. And then, so part of your admin's workflow might be they have a virtual machine that they run from their PAW that they can do higher risk activities like surfing the web, checking email, and then from their physical host, they only use that to do administrative activities. So they're not surfing the web, they're not checking email from that physical host. Okay, we're going to move on to endpoint security. We've got a lot on this slide. So something I see pretty much everywhere I go is default credentials for devices. So this can be printers, network switches, cameras, DVRs, access control systems, UPS devices. I always find at least one device with default credentials everywhere I go. Printers is pretty much every time, 100% of the time. We see no or limited network segmentation, no management network. Sometimes it's a flat network. Sometimes they get different subnets for servers or workstations, but there's no ACLs at the network level, or there's no host-based ACLs. So once you gain a foothold on any system in the network, it's pretty easy to move to other systems that are more critical assets. End-of-life systems, unsupported software. So we commonly see unsupported operating systems, unsupported databases, SQL, unsupported third-party applications. Patch management, this includes third-party applications. We also see two patches that every organization should ensure that are patched are MS-1710 and Bluekey, because those are wormable Microsoft vulnerabilities. These are vulnerabilities that, if malware gets a foothold in your environment, it can move laterally to any systems that don't have these patches applied. And we're going to talk here in just a minute about how just having one unpatched system can put your entire domain at risk. We also see overly permissive file share permissions. So a common technique that we use when we do testing, we set up a unprivileged user account, so it's just a regular user, and then we scan the entire network for file shares to see what file shares that user has read and write access to. So it's representative of what, every domain user has read or write access to in the environment. We also see a lot of issues with endpoint security. So this is systems that are either missing antivirus or endpoint security. They've got out-of-date definitions or out-of-date versions of the agents. So if you're not actively maintaining your endpoint security software, you can actually introduce vulnerabilities to your environment. So endpoint security software, they can have privilege escalation vulnerabilities. Occasionally they have remote code execution vulnerabilities. So if you've got an outdated semantic endpoint manager, for example, you might be exposing your endpoint management server to compromise. We also see full disk encryption missing from laptops. We see that pretty much everywhere we go. Legacy protocols that are enabled. So these protocols include SMP version 1, and then LLMNR and NetBIOS name services. We're going to cover that here in just a bit more in depth in a minute. We also see that there are no system hardening baselines applied. So Microsoft has a free toolkit that are basically group policy objects you can import, and it's their recommendations for locking down those the Windows operating system. I've got a slide later on that I'll link to for your reference for that. We also see no hardening for Microsoft Office, so no restrictions for macros. These days, malware is commonly deployed to environments using macro malware. So you can actually use group policy to ensure that users cannot enable macros for documents downloaded from the internet. That's a really good control you can implement to reduce your exposure to that type of malware. We also see, more commonly, no insight into PowerShell or scripting activity in the environment. So threat actors, and as well as malware, are using PowerShell and other common administrative tools to achieve their objectives. So you should have some insight into PowerShell in your environment, either using an endpoint security platform or just enable PowerShell logging through group policy. So by default in Windows, whenever it needs to resolve a name to an IP address, it's going to use DNS. But if it fails to resolve using DNS, it'll fall back to using a legacy protocol like LLMNR or NetBIOS. So on the left there, you can see a diagram. This is kind of what it looks like. The computer basically sent out a broadcast that says, "Hey, who is file server?" And the DNS server is like, I don't have an A record. I can't resolve that. It then sends a broadcast out to every computer on the network to say, "Hey, is anybody a file server?" If I'm a bad guy, and I don't even have to have a physical device connected to the network, I could just have a foothold on a system I've compromised. And there's a free PowerShell tool called Envy right there. They can run in PowerShell and just sit and listen and wait for these broadcasts. It's a way for you to do a relay attack, so you can actually authenticate to a system using the credentials that are exposed in that broadcast, or you can crack the hash offline. I've actually used this tool to crack domain admin password hashes. So this is something you should be disabling. It is disabled by default in Microsoft's security baselines. So now we're going to talk about malware that's actually used some of these tools we've talked about. Emotet and TrickBot. This is a really advanced modular banking Trojan that has caused some significant impact to a lot of environments. I'm going to show you a kind of a diagram of how this works. So the way this works is typically the user will receive a phishing email. It could be a macro Word document that's attached in the email, or it could be a hyperlink to OneDrive, Google Drive, Dropbox. Whenever the user accesses that link and downloads this attachment, when they open it, it's instructing them to enable macros because it's protected. And when they enable macros, it will launch a PowerShell stager to download a binary and executable. This binary is the first stage of the attack. It's emotet. So it's really good at establishing persistence. So it typically sets up persistence through scheduled tasks, modifying the registry. It will download and grab additional payloads. Usually the payload that it'll download is called TrickBot. Now, I've encountered this malware on 2 different times through incident response, and both times the entire domain was compromised. Every computer on the network, every workstation, every member server, and the domain controllers were compromised by this malware. So it typically disables antivirus. It harvests data. So if users are storing credentials in their browser, it will exfiltrate it. It dumps the credentials of the logged in user. If the user is a domain admin, it will dump the credentials and then use that to move laterally in the environment. That means if you have a system with a domain admin logged in on an affected system with TrickBot, it will steal those credentials and will infect every system on the network. It will also spread by brute forcing the local admin password. So if you don't have random unique passwords using a tool like Laps, or if you're not blocking local admins from you doing a network logon, it can pivot that way as well. If you have unpatched systems like that are missing MS17, the patch for MS1710, it can exploit those systems as well. So the final stage in this attack chain here is it drops a payload called Riot. That's a ransomware binary. So you basically end up with credentials of all your users in your environment exfiltrated, and then all of the systems getting encrypted simultaneously with ransomware. Now, I've seen in some press releases before where organizations state that their systems were hit with ransomware, but no data was exfiltrated. That's a pretty big assumption to make, because if they're able to encrypt your data, they probably were able to exfiltrate your data as well. Something I wanted to point out. So this is a playbook I would highly encourage you, especially if you're involved with incident response efforts in your organization. You should have a playbook for encountering this type of malware. And just as a reference, the organization that we responded to, we had to take every system offline the network one at a time and clean them up because it is very good at propagating throughout the network. You have to change passwords of every account that's been compromised, and you got to take them offline to clean them. You cannot be logging into infected systems with highly privileged accounts because it will propagate using those account credentials. So we're going to cover common security controls now. So we typically will assess the effectiveness of security controls like egress filtering. So this is filtering that's in place on your network perimeter at the firewall out to the internet. So we typically see pretty good ingress filtering, so filtering coming into the organization, but typically no restrictions on filtering outside the organization. You really should only be allowing traffic that's necessary for business purposes outbound, or at the very least, so there's 2 different approaches. Whitelisting is only allowing outbound what's necessary for business purposes, and then blacklisting is blocking what you know to be bad. At the very least, you should be blocking common ports and protocols that are used by threat actors outbound to the internet. Inadequate web content filtering, so we are typically find that the web content filter isn't configured as strong as it could be. So some web content filtering vendors allow for you to block uncategorized websites. So threat actors they spin up new domains all the time, and there's kind of this lag in between whenever they spin up new domains and when they're categorized as malicious by the vendor. If you're blocking uncategorized or newly seen domains, that's a way to kind of mitigate your risk there. We also see organizations that either they don't have intrusion detection capabilities or they have an IDS, but no one's monitoring it. It's not actively being maintained. Also, security alerts. If you're not fine-tuning your security controls and you're getting a bunch of noise, more often than not, these security alerts end up being ignored. We also see that there's no advanced email protection. So Microsoft, for Office 365, they have something they call Office 365 Advanced Threat Protection. You can set up safe attachments policies, which ensure that any attachment delivered in an email gets scanned in a malware sandbox before it gets delivered to the target. and also safe links policy. So this is URL rewriting. So if there's a email a user receives that has a URL, it will get rewritten to a Microsoft address, and then it gets scanned to see if it's hosting malware before the user is allowed to click through that URL. There's other vendors out there that have similar type capabilities, including Proofpoint and Symantec. I'm just using Microsoft as an example. We also see that there's no formal security awareness program most of the time. We also see internet-facing hosts are not separated into a DMZ. If it's internet-facing, you really want that in a DMZ, and you want to have filtering in place between your DMZ and your internal network. So some commercial solutions we recommend for security awareness training. KnowBe4 is a favorite of ours. Our preferred vulnerability scanner is Tenable Nessus. For advanced DNS protection, we highly recommend Cisco Umbrella. Advanced email protection platforms include Office 365 Advanced Threat Protection, and then Proofpoint's equivalent is their targeted attack protection platform. And now the moment you've all been waiting for free tools and informative resources. So the informative resources will start at the very top there. US CERT, that's the United States Computer Emergency Readiness Team. They've got a lot of good alerts and advisories on ongoing incidents and malware campaigns. Incident response playbooks. If you go to incidentresponse.com, there are some free playbooks for different types of incident response scenarios, including malware, denial of service, mailbox compromise. Highly recommend you check that out. Shodan, this is kind of like the search engine for the internet. If you've never used it, I highly recommend you check this out. This is actually a tool that we'll use to supplement our vulnerability scanners and discovery scanners when we do an assessment. And I've actually, one time when I was doing an assessment, I typed in the IP address of our client had their ISP's router had some ports and protocols that were internet facing that looked a little suspicious to me. So whenever I put in the IP in Shodan, it did a banner grabbing on the point-to-point tunneling protocol and told me, when I looked at it, it said that the host name was hacked. So we inferred from that our client's ISP's router had been compromised because they were using default credentials. Another free tool you can check out is Email Exposure Check Pro. So this is a free tool from KnowBe4. This will check to see which users in your organization have their work emails that have been exposed in various data breaches. I mentioned Tenable Nessus as a vulnerability scanner on the previous slide. If you don't have the budget for a commercial vulnerability scanner, check out OpenVOS. It's an open source vulnerability scanner. Also, a free DNS security service is Quad9. There's no monitoring with this. There's no reporting, but you can benefit from their threat intelligence to stop queries to malicious domains in your environment. I mentioned the Microsoft Security Compliance Toolkit. This is a free toolkit from Microsoft, which allows you to implement security best practices for workstations, servers, and Microsoft Office. The group policies are ready to go. You just have to import them and tune them to your environment. The Center for Internet Security has a Secure Suite membership, and this is free for public sector clients. It's kind of the equivalent to the Microsoft Security Compliance Toolkit. Account security tools, we mentioned weak passwords. KnowBe4 has a free tool called Password Exposure Test that anybody can use. No technical knowledge whatsoever to use it. You can get a list of all the users in your environment that have weak passwords. Highly recommend you check that out. Microsoft's free tool, the Local Administrator Password Solution, that's the tool that ensures that all passwords are random and unique for your member workstations and servers. Some additional free security tools. So from KnowBe4, they have a few different tools. One is a Fish Alert button. So this is a add-in that you can install in Outlook that gives your users a button in their Outlook ribbon they can click, and it will automatically send a user, or it will send a email to whatever distribution group you specify to inform them of a suspicious email. They've got another tool called Second Chance. So this is a tool that when your users click a hyperlink in their email, they'll get a pop-up that says, hey, are you sure you want to click through this link? That gives them a second chance to back out of clicking a suspicious link. They've also got a free ransomware simulator you can run in your environment and see how effective your endpoint security is at stopping 16 different ransomware scenarios. If you don't have the budget for some of these tools, there's a free phishing platform you can use, open source tool called GoFish. And then also, if you don't have the budget for security awareness videos, CoFence has some free computer-based training that you can download and import into a LMS system. I know I covered a lot, so does anybody have any questions?
The labs program, is that only for the administrator username, or, 'cause I think you're supposed to disable all those and create a new user.
Okay, so Microsoft used to recommend disabling the built-in administrator account for workstations and servers. They now no longer recommend doing that because that free tool Labs manages them. So Labs is managed from Active Directory. So whenever you log into Active Directory and you go and look at a computer object, if you look at all the attribute editor tab, it would just have the password that is unique and random for that computer there. And then they've got a PowerShell tools. You can run a PowerShell command line to get the password for that computer. And then they've got a GUI. So they've got a Labs UI you can run. You just type in the computer name and click search, and then it tells you what the password is for the local administrator account on that computer. And then Microsoft also recommends that you block local accounts from being able to do a network logon. So that's like log on over a network. So like, to give you an example, has anybody here ever used administrative shares? Like if you are hitting a system over SMB, $, admin $. So if you configure a group policy to block network logon using a local account or like a domain admin account, it mitigates malware like TrickBot from being able to move laterally. Anybody else have any questions? Thank you very much for your time, everybody.